Hi, Algebra 2. In this video, I'm going to be going over how to solve radical equations. So our instructions are to solve each radical equation using the appropriate inverse operations. Then we need to verify our work in order to identify any extraneous solutions. So notice that both of these equations have square roots in them. So since we're using inverse operations to solve, at some point in both of my equations, I'm going to need to do the inverse of a square root, which is squaring. So that'll help us to get through solving each of these. So I'm going to start with the one on the left that says the square root of x minus 1 plus 8 is equal to 4. So when I'm trying to solve an equation, that means I'm trying to get x by itself on one side of the equation. When I'm solving a radical equation, I always want to make sure that in order to solve, I start by doing the opposite operation of whatever's outside of my square root. So if I look at this equation, I have square root of x minus 1. So x minus 1 is inside the square root, and then I have the plus 8 outside the square root. So my first step to solve a radical equation is always to get rid of anything outside of the root first. So if I want to get rid of the plus 8, I need to do the opposite, which is minus 8 on both sides. So that gives me square root of x minus 1 on the left side, since the 8 is gone now. And then 4 minus 8 gives me negative 4. My next step is, now I'm left with square root of x minus 1 inside the square root. Okay, I can't get rid of the minus 1 yet because it's stuck inside the square root right now. The first thing I need to do, I'm trying to get x by itself, I need to get rid of this square root. So once you have the square root part of the equation isolated, your next step is always to get rid of the square root. And to get rid of a square root, we do the opposite of square rooting, which is to square it. So I'm going to square both sides of my equation. A square root squared cancels out. So it leaves me with whatever was under my square root, which is x minus 1. And negative 4 squared, that's negative 4 times negative 4, which gives me positive 16. Now, of course, this is just a one-step equation. I need to get rid of the minus 1 in order to isolate x, so I'm going to add 1 on both sides, and that gives me x equals 16 plus 1 gives me 17. Now, my next step is always to verify. Verify means I need to substitute the solution I got for x back into the original equation, simplify, and see if I get a true statement. So that means, since I know I've found that x is 17, I'm going to go take my original equation, copy it down, make sure you plug it into the original equation, not any of the steps after you started solving, but the very original equation that was given. So I'm going to rewrite my original equation, but wherever I see an x, I'm going to replace it with 17. So instead of writing x minus 1 under my square root, I'm going to write 17 minus 1 plus 8 equals 4. And this is my verifying step. So now make sure you don't try and start solving anything. We don't have anything to solve for because the x is gone now. We are just going to simplify the left side of the equation. The right side of the equation is already just one number, 4. So that means I need to simplify the left side of my equation, and I need to go in my order of operations. So I know that I always need to do what's under the root first. 17 minus 1 gives me 16. And then my order of operations tells me I need to do my square root before I add. So square root of 16 gives me 4. And then my last step is to add 4 plus 8, which gives me 12 equals 4. Now, obviously, that is not a true statement. 12 does not equal 4. So that tells us that our solution is extraneous. So extraneous means that while we followed the correct steps to solve the equation, we got a solution that doesn't actually work when you plug it back in. There's actually a step that we had in our equation that could kind of tip us off to knowing we're going to get an extraneous solution. So if you think back to our very first step when we were solving, the first thing we did was we subtracted 8 on both sides. When we subtracted 8 on both sides, we got the equation square root of x minus 1 equals 4 minus 8 gave us negative 4. If you look at this equation, you can tell that there is not going to be a real solution. We're only going to get an extraneous solution. The way I can tell that is because I have a square root of something equal to a negative number. Now I know that I can never square root any number and get a negative. There's no number I could possibly square root to get a negative. I know I can't have a negative under the square root, but I know that if I take the square root of 0, I get 0. If I take the square root of any positive number, I'm going to get a positive number. There's no possible number I could have under a square root that would give me -4 or any other negative number for that matter. Okay, so even though we squared both sides, we got a positive 16, and then we were able to solve. The fact that I had a square root equal to a negative number kind of tipped me off to the fact that I was going to get an extraneous solution. You still have to finish solving and show that your solution is extraneous, even if you get to that step and you can tell. But just know that that is another way of knowing that you're probably going to get an extraneous solution. You still need to solve, you still need to verify. And when you get a false statement, when you're verifying, that tells you you have an extraneous solution. All right, so let's go on to this other example. It's 3 times square root of 2x plus 6 is equal to 12. So like I said before, we always need to get rid of what's outside of the root first. So in this case, sometimes people think the 3 is a cube root. It's not. If it was, it would be very, very small, and it would be in that spot. But it's not. It's big. It's multiplying the square root. The 3 is multiplying the square root, and it's outside of the square root, so I need to start by getting rid of the multiplying by 3. So I do the opposite of multiplying by 3, which is divide by 3 on both sides. And when I divide by 3, that leaves me with my square root of 2x plus 6 equals 12 divided by 3 gives me 4. Now I have my square root part isolated. Even though there's still stuff under the square root, there's nothing left outside of the square root. And that's when I know my next step is to get rid of the square root. To get rid of a square root, we do the opposite of square root, which is to square both sides. So I'm going to square both sides. The square and the square root cancel out. It leaves me with whatever is under my root, which in this case is 2x plus 6. And 4 squared, that's 4 times 4, which gives me 16. Now I just have a two-step equation. Remember, you always get rid of addition and subtraction, and then you get rid of multiplication or division. It's like the backwards of PEMDAS. So I'm going to subtract 6 first. So 2x equals 16 minus 6 gives me 10. And then lastly, I divide both sides by 2 to get x is equal to 5. Now, of course, I'm not done. I have to verify. And verifying means I'm going to take the solution I got for x and substitute it in for x in my original equation. So wherever I see x, I'm going to replace it with a 5. So I have 3 square root of 2. I can't just write a 5 because then it'll look like 25. So I need parentheses to show I'm multiplying. 2 times 5 plus 6 equals 12. So I go in my order of operations to simplify the left side. I'm not moving anything. I'm not dividing anything on both sides or anything like that. I'm just simplifying the left side. So, and seeing if it's equal to 12. I always start with what's under my square root, and I have multiplication and addition under the square root. PEMDAS tells me to start with multiplication. So 2 times 5 gives me 10. I'm still not done with what's under my square root. I have 10 plus 6, which gives me 16. Now I can take the square root of 16. That gives me 4. So I have 3 times 4 equals 12. And 3 times 4 does give me 12. So I get 12 equals 12. So x equals 5 is not an extraneous solution. It's all good. It works in our equation when we substitute it back in. And that makes sense because kind of thinking back to how we talked about the last example, when we got the square root by itself, we had square root of 2x plus 6 equals 4, positive 4. And since the square root wasn't equal to a negative number, we know it is possible to get the square root of something is equal to 4. So it makes sense that we didn't get an extraneous solution, okay?